So good afternoon. My name is David Muller from Homes England. So delighted to welcome you to our autumn learning program. This is a series of knowledge sharing topics that you have told us are of interest. And today's event is about developing and applying water neutrality strategies. The autumn learning program is brought to you by Homes England's Local Government Capacity Centre. This slide summarizes what the LGCC does. I'll just leave it there for a second for you to read through that. All right, so if we go on the next slide, please. So the Autumn Learning Programme is just one of the tools that's offered by the Local Government Capacity Centre. Here are some of the other ones. Also, you can see the recordings of previous sessions available on YouTube. We also have a Housing Information Hub on gov.uk, the New Homes Fact Sheet, and the Capacity Analysis Tool. So that's a tool to assess your organizational capacity to deliver regeneration. So have a look at those useful resources as well. Can we have the next slide, please? This is today's agenda. So I'm doing the introduction moment. We will also have a few words from Phil Harker from Homes England before we pass over to James Ellaway from WSP, who will be presenting today's session. And about 3:10-ish, we will have a Q&A session. So we'll be answering the questions that you've posted in the chat. And there'll be a chance for people to ask other questions of the panel. So without further ado, I'll hand over to Phil Harker, please.
Thanks very much. And welcome everybody. I'm just going to do a short introduction around sort of water neutrality. And it sort of occurred to me that the phrase water, water everywhere, not a drop to drink, although it comes from the famous poem by Samuel Taylor Coleridge from the Rime of the Ancient Mariner, reflecting life at sea, it's also beginning to have more of a context on land. So in the UK, with our history of rainy days, you could be forgiven that water is plentiful and readily available for us to use where, when, and however we like. However, so significant parts of the country are under ever more increasing water stress, impacting both the natural environment and public water supply. Climate change, increasing demand for water, and the potential impact to the natural environment are real issues that we have to be faced and managed. Homes England are working with numerous partners and stakeholders, including water companies, the Environment Agency, Natural England and house builders across a number of areas to unlock growth and find solutions to protect the environment and enable long-term sustainable development. In doing so, we have stepped into the world of water, and along with others, we are working to find the short to long-range solutions that enable us to continue to deliver the much-needed housing across the country. We are supporting the planned growth of Cambridge, where 99% of water supplied comes from aquifers, which also provide base flow to chalk streams that support important habitats. Therefore, the need to provide a long-term plan to meet the growth and protect these habitats is critical. As part of the Cambridge Water Scarcity Group, we are working with others to support the short, medium and long-term solutions that enable the growth and setting up a water examples include setting up a water credit scheme, bringing forward nature-based solutions and supporting water companies to bring forward their medium and long-term supply solutions, including a new water transfer scheme and a new reservoir. However, I'm not going to expand on these as I'm going to now introduce James Ellaway, who is Technical Director at WSP, who is going to give us much more of a briefing on water stress and water neutrality, and will cover the sort of solutions that we can bring forward to enable development come forward. So over to you, James.
Great, thank you, Phil. That's a very good summary of what I'm just about to talk about. So you could have done the slides, I think. Right, good afternoon, everyone. Thank you for joining us today. I'm James Ellaway. I'm a Technical Director in WSP's Water Strategic Advisory Team. I've got 30 years experience now in the delivery of water and environmental projects, both in the UK and overseas. I lead WSP's water and nutrient neutrality services and have significant experience of working for developers on small through to very large projects. I've recently delivered a water neutrality strategy that unlocked planning for a 32-home scheme in the Sussex North water resource zone. And I'm currently leading a development scale integrated water management strategy for a 3,000-home scheme in Sussex as well. Earlier this year, I was working for DEFRA, as Phil has just alluded to, the water credit scheme in Cambridgeshire, and developing recommendations for that scheme. Which is designed to facilitate new development in an area of very intensive growth. I'm pleased to say that shortly we'll be continuing that project to develop the operating processes and a manual. I'm supported by brilliant colleagues with expertise in water reuse, SUDS, engineering, hydrology, hydrogeology, landscape design, to name a few. And water neutrality strategies really are a team effort because they're so multidisciplinary. The focus of my talk today is the development and application of development scale water neutrality strategies that will accompany planning applications in seriously water stressed areas. And I will also provide some considerations for local authorities should they need to develop their own water credit scheme in the future. Next slide, please. So quickly diving into some context, going to look at the UK water scarcity challenge that we face at the moment. Next slide, please. But before we dive into the details, I think it's helpful that we define what is meant by water scarcity, water stress, and serious water stress. So as you can see here, the UN Water Programme defines water scarcity as a relative concept, which is based on the amount of water that can be physically accessed. So water scarcity therefore increases when, or reduces when increases when demand increases, or when the quality or quantity of supply decreases. A territory, which could range in scale from, a water resource zone, a country, a region, is assessed as being water stressed when 25% or more of the renewable freshwater resource is extracted for human use. And in England and Wales, the water industry regulations define an area as in serious water stress when the household demand is a high proportion of the current effective rainfall available to meet that demand. And this can be based on the current supply demand or future projections as well. Next slide, please. So as we all know, rainfall is higher in the west of the country than it is in the east of the country, as we can see here on this figure from the Met Office. And that should mean the south and east of the country are more susceptible to water scarcity and stress. Next slide, please. And indeed, that is the case. As we can see here, much of central and southern England are flashing red. The map on the left shows the water stressed areas classified by the Environment Agency in 2007, and they're graded from low to moderate to serious. As you can see, large areas of eastern, central and southern England were already classified as seriously water stressed as far back as 2007. And that covers a population of around 31 million people. You can see on the right that just 14 years later, the Environment Agency had upgraded or maybe downgraded Wessex Water, Severn Trent, South Staffordshire Water to seriously water stressed, plus a handful of smaller water companies, including Cambridge and Portsmouth. A further 9 million people live in these regions. So a total of 40 million people in England currently live in areas defined as being seriously water stressed. With the population of England being 57 million or thereabouts, 70% live in seriously water stressed areas, which is quite astonishing. These areas essentially mirror the rainfall pattern that we've just seen, although they don't extend up the east coast of England, possibly because of a lower population density and greater reservoir storage in those areas. The Environment Agency assessment of water stress takes a long-term view of the of the availability and the demand for public water supply, rather than just a snapshot of short or peak periods. It accounts for future population growth, climate change, environmental needs, and increased resilience. And it reflects and supports the commitments that water companies have made to reduce leakage and water consumption. The designation of an area as seriously water stressed permits the water companies to consider introducing compulsory water metering to try and reduce demand, alongside other demand management measures. Interestingly, it also permits local authorities to tighten the new home water use standard from 125 litres per person per day to the 110 litres specified in Part G of Schedule 1 and Regulation 36 of the Building Regs 2010, if you care to look it up. A written ministerial statement by Michael Gove in December last year encourages local planning authorities to work with the Environment Agency and delivery partners to agree standards tighter than 110 in areas where water scarcity is inhibiting the adoption of local plan or the granting of planning permissions for homes. And that was introduced because of the situation in Sussex North and Cambridge. So the classification of seriously water stressed areas is important in unlocking powers for local authorities and the incumbent water companies to do more and to require others to do more to rise to the challenge. Next slide, please. So as Phil said, climate change is going to worsen the situation. And what we can see here is the WRI aqueduct map, which is a brilliant resource. I'd recommend you all go and have a look and play with it. It provides global mapping that shows the risk of water stress with various epochs of climate change. And you can see here that this is showing the pessimistic scenario for the UK for 2030, 50 and 80. Now, I selected the pessimistic scenario because the business as usual and optimistic scenarios didn't capture the existing severity or distribution of water stress and scarcity in the UK, which is not a positive direction of travel, I fear. And even the pessimistic situation for 2030 doesn't really capture the current acute issue in Cambridge. So as shown here, the aqueduct model forecasts water stress worsening across England over time, with extremely high stress in the Thames Valley, high stress in the southeast, and medium to high stress in East Anglia, the Midlands, and up into the northwest and northeast. And if anything, this still underplays the acute situation in Sussex North and Cambridgeshire. Next slide. Right, so I know this is a Homes England event, but I have the great good fortune to live in a village near Edinburgh. And most people think of Scotland as being very well watered. However, rainfall patterns are changing very quickly, even up here. And if you cast your mind back to the Met Office image earlier, it shows that the east coast of Scotland is actually very dry, and it has lower annual rainfall than my hometown in West Sussex, strangely enough. So we do have issues up here as well. Next slide, please. So despite the aqueduct map showing future water stress in Scotland as low, we already experience water scarcity in the summer months. This is the SEPA water scarcity report for 30th of June 2023. Now, this is different to the Environment Agency's sort of designation of seriously water stressed areas, because this is a snapshot in time, and they do this every week during the summer period. What is unusual is that this isn't particularly unusual. There were similar reports in previous years. And you can see, quite astonishingly, that approximately half of Scotland was at moderate to significant water scarcity, with most of the rest at alert level. This is a growing problem in Scotland. It's becoming more extensive. It's affecting the wetter western regions, and it's also occurring earlier in the summer than in recent years. I used to live on the west of Scotland, but it was too wet, which is partly why I moved to Edinburgh. And that is also an issue, because while this report shows the problems being most severe in the West on this occasion, there's a long-term trend of increasing population in the drier east of the country, where water resources and storage are more constrained. And that's a big problem that Scottish Water have to grapple with. Next slide, please. So, however, the situation is much more acute in the south and east of England, particularly in the Sussex North Water Resources Zone shown here. This zone encompasses Crawley Borough Council, Horsham District Council, parts of South Downs National Park, Chichester District Council, West Sussex County Council, and Mid Sussex, I believe, as well. In September 2021, Natural England informed local planning authorities that new development applications in this region must not add to the existing water demand. This situation arose because Natural England was unable to conclude that existing groundwater abstraction at Hardham was not having an adverse impact on the Arun Valley SAC, Special Area of Conservation, Special Protection Area, and Ramsar site. So those are all habitats sites, what were formerly known as European habitat sites. So as a consequence of this decision, all planning applications in that water resource zone, and that includes domestic and non-household, must achieve water neutrality. That means that the total demand for water with the new development must be the same as it was or lower than the total water demand before the development. And this has caused significant delays to new developments in the region, while developers and local authorities try and come up with solutions. And while many people may be aware that water neutrality is a requirement in Sussex North, water scarcity and water neutrality are issues that already affect the UK more widely. Next slide, please. East Anglia is the most water-stressed region of the UK. Cambridge has annual rainfall of just 575 millimetres a year. And that's approaching the definition of a semi-arid zone, which has a range of 250 to 500 millimetres a year. It is astonishingly dry. In contrast, in Sussex, it's around about 800, 750 to 800. The low rainfall and high levels of development in Cambridgeshire have resulted in forecasts of significant supply-demand deficits by 2050, actually for the majority of East Anglia, as you can see in this extract on the left from the Water Resources East Regional Water Resources Plan published last year. The darker the red, the worse the supply-demand balance becomes. And yet the demand for water is growing, with one of the highest rates of new housing development in the country, and ambitions to build 250,000 homes in the region by 2040. And it is, of course, also home to very significant nationally and internationally important businesses and research. And there's also the wider Oxford-Cambridge arc, where development is proposed. So in response to this water scarcity challenge, Cambridge City Council, South Cambridgeshire District Council, Huntingdonshire Council, and Cambridge Water are considering the implementation of a water use target of 80 litres per person per day for the new developments, down from the 110 we saw earlier. However, the situation is developing very rapidly, and in the last 18 months or so, this means that this approach of trying to moderate water consumption through new developments is insufficient to address the severity of the issues. Next slide, please. And one more, please. Okay, thank you. In 2023, the Environment Agency objected to new housing developments in Cambridge Water's supply zone because they don't have confidence that Cambridge Water can supply new developments without increasing abstractions from the aquifer, and then adversely affecting Water Framework Directive watercourses such as the Paranta and Cam. And essentially those are already damaged, and the Environment Agency is seeking to put license caps on the abstraction to reduce the volume that is already extracted to reduce the adverse impact that is already occurring. And so that means much less water will be available. So this has essentially put a moratorium on new developments in Cambridge, unless schemes have no impact on the potable supply. And it is in essence a de facto water neutrality requirement. Interestingly, this is being driven by the Environment Agency on a Water Framework Directive argument, rather than Natural England from a habitats perspective, as is the case in Sussex North. And the reason that is interesting is because the WFD, Water Framework Directive, applies to every watercourse in the country. And so it is a much lower threshold than determining that there's an impact on a habitat site, and there are fewer habitat sites. So this therefore opens up the prospect, I think, of greater contagion of a Cambridge-style situation across the wider water-stressed areas that we've seen earlier. Thank you. Next slide. This is just a few examples of the situation in the local press. And one more, please. Causing very significant issues for developers in the region. And I think one or two more. So very significant population growth by 2040. Thank you. So water scarcity is already constraining housing developments in Sussex North and Cambridge, as we've just seen. But more broadly, commercial and agricultural developments are being refused a new potable supply or an increase in their existing potable supply across East Anglia, and that's stretching into Northamptonshire and Bedfordshire as well. Earlier in the summer, there was a chicken farmer who was refused permission to increase his potable supply. So he's building his own reservoir. I don't know how he's going to fill it, but I'm sure he's thought it all through. And there was a small brewery as well in press the other day. They've been denied more water, so they can't expand, and they're looking to leave East Anglia for wetter climes. So water scarcity and water neutrality challenges are already here. They're real. They're going to become more prevalent over the coming years with climate change. And I think the situation is developing more rapidly than many expected, and is running ahead of the required policy responses. And as a consequence, it's taking a long time to resolve the issues in Sussex North and elsewhere. So earlier this year, Phil said that there was funding for the Department of Levelling Up Housing and Communities to DEFRA to support and inform their policy development process in the Cambridge zone. As part of this, I delivered a project to inform the governance and structure of a water credit scheme, similar to the one in Sussex North, known as SNOWS. Colleagues of mine delivered other projects looking at water efficiency retrofitting to non-household properties to save water and generate credits that could then offset demand for new development. And we also looked at opportunities to reduce agricultural water usage. So I think it's clear that we will all have to adapt over time. As consumers, we're going to have to adapt to using water more wisely. Developers will have to redesign their standard homes to incorporate water efficiency measures, rainwater harvesting, and potentially grey water recycling. Or they may consider implementing those at the development scale instead through an integrated water management approach. But the challenge is real. Next slide, please. So while water neutrality is a requirement in Sussex North and a de facto requirement in Cambridge, we've seen that water scarcity is a more widespread phenomenon. A new development in a seriously water-stressed area may need to be designed to a water use standard of 80 or 85 litres per person per day, which can add some costs to a development. But achieving water neutrality requires a much more comprehensive approach and is very challenging, time-consuming, and expensive. And we will have a quick trot through the key components of a water neutrality strategy. Next slide, please. So water scarcity may be addressed by using any of the steps in the water neutrality hierarchy we see here. But achieving water neutrality will require consideration of all three steps. So as we can see here, step one is to reduce water usage at source. And so that means fitting water efficient fixtures and fittings into the home. There may be control valves as well to reduce the flow rates. And that can get per capita consumption down from 110 litres per person per day to around 80 to 85. With the addition of a step two, maybe rainwater harvesting or grey water recycling, to provide a non-potable supply for toilets, washing machines and outside use, we can get down to around 55 to 65 litres per person per day. But that is really pushing it, and the acceptability of that to the purchasers and tenants of homes may become problematic and challenging. And so the remaining PCC must be reduced to zero in step three to bridge the gap to water neutrality. And that's where it gets really very expensive. That can be achieved either through direct offsetting, where a developer pays for reductions in existing water demand at existing properties to offset against the new demand. It could be achieved through the purchase of credits from a water offsetting scheme such as SNOWS, or the one that's being developed in Cambridge. It might be through the development of an alternative water supply. If a property is near the boundary of the water resource zone, it's theoretically possible that they might be able to connect into a different water resource zone, or development of a borehole into a groundwater resource that is disconnected from the main aquifer. And it may be possible to adopt an aquifer recharge approach to close the loop, injecting rainwater or very high quality treated effluent from the development back into the groundwater to offset the increased abstraction. But whichever option is chosen, the complexity and cost increase as we progress through steps 1 to 3. Next slide, please. Thank you. So in the 3 steps in the hierarchy we've just seen can be addressed through a simple development scale integrated water management approach. So as shown here, this can focus on in-home water efficiency as being the first course of action, water reuse and recycling, and a range of other options to minimise and offset potable water demand on the development. Other considerations in a full IWM model would include sustainable drainage, flood management, consideration of the Water Framework Directive, carbon net zero, and other factors. And elements of these can be factored into the development scale approach as applicable. But this offers a good model to follow. Next slide, please. So looking first at in-home water efficiency, as we've seen, the local planning authorities are proposing a consumption target of 80 litres per person per day in Cambridge. In Sussex North, it's 85. So careful selection of water efficient fixtures and fittings in a new home can reduce the PCC to these targets on their own, as shown in this example. The use of dual flush toilets, low flow taps, highly efficient appliances, a smaller bath and a lower flow shower are all recommended and required to achieve that target. However, as I mentioned earlier, the acceptability of that approach to home buyers may become challenging as the PCC is further reduced. And many developers have previously been unwilling to design homes with a standard lower than 110 because of concerns that customers won't buy them. However, I think now that lower PC targets are being mandated in certain areas, that competitive risk between developers dissipates as they're all in the same boat, and all new homes in an affected catchment must be built to the same standard. But there are different ways of slicing and dicing that to a certain extent. Thank you. Next slide. So the PCC, per capita consumption of 85 litres in our example home, can be broken down into the non-potable demand of 28.5 litres, This is the demand for water to supply the toilets, washing machine and external use, which of course doesn't have to be of drinking water standard and could be supplied by non-potable water. The non-potable supply for that example home would be 43.4 litres. So that's from water from showers, baths and wash basins, excluding the kitchen sink. And that could be captured by a grey water recycling system. As this water is not typically contaminated with food waste, it requires minimal treatment before being recycled into homes. And as you can see, the supply is greater than demand. And so grey water recycling can reliably meet the non-potable demand throughout the year. And so in our example home, subtracting the non-potable demand of 28.5 litres, the PCC of 84.8, reduces the PCC to 56.3. And that is a very sizable reduction from the starting point of 110. Next slide, please. So the non-potable demand of 28.5 litres per person per day could also be met through property level rainwater harvesting systems, which could collect, store, treat rainwater for use in the house. Assessment would be required of the rainfall frequency, the rainfall depth, intensity, and the roof area to determine whether the non-potable demand could be consistently met throughout the year. And given the limited roof surface area available for collection and the lower rainfall in drier parts of the country, which is of course where water scarcity and water neutrality are most acute, this may not always be possible. In such cases, a centralized rainwater harvesting system could be used to capture rainwater from all roofs in a development, including commercial buildings for mixed-use developments, and convey it to a large underground storage tank or series of tanks. The storage volume, if you were to take this approach in Sussex North, would require storage of 35 days of supply to cover dry periods. And the rainwater would be treated through a centralized treatment plant prior to being pumped back into the individual homes. This is the approach that we're adopting in Sussex North. An alternative approach is actually stormwater harvesting. So that differs from rainwater harvesting because it captures and reuses water that drains from other impermeable areas in the development, such as roads, footpaths, and landscape areas, and can also take the roof runoff as well. So the larger collection area generates larger volumes of water, obviously, which requires more storage, but also means that stormwater harvesting may be better suited than rainwater harvesting in areas with low or less consistent rainfall. The large volumes also permit the construction of landscape scale surface water bodies for storage that can enhance the development and contribute to a landscape-led scheme. Stormwater will, of course, have higher levels of contamination from road runoff, animal feces, and entrained sediment and vegetation. And so it would therefore require greater treatment than rainwater collected from relatively clean roofs. So there would be an increase in the cost of that. Next slide, please. Thank you. So if rainwater or stormwater harvesting aren't suitable, the non-potable demand could be met by installing a grey water recycling system, as we've seen in our example of the home earlier, with 43.4 litres being captured every day. And as this exceeds the non-potable demand of 28.5, grey water recycling provides a consistent supply throughout the year, meaning that this approach is particularly useful in drier parts of the country. So a grey water recycling system could consist of an individual property level system, such as the hydro loop pictured here on the left, looking very snazzy. You can, I think, have any design printed on that front panel. And they cost from £5,000 per dwelling. Or, for example, the equality system on the right, which can be incorporated into individual properties or scaled up for use in high-rise developments and commercial buildings. And they're widely in use in the King's Cross development in London. However, there's still a reluctance for developers to install grey water recycling systems because of the yuck factor and the concerns about how that would affect their clients. Such systems are typically designed, installed and maintained by a third party, and incumbent water companies are reluctant or possibly prohibited from installing grey water recycling systems because the drinking water regulations require them to supply drinking water that is wholesome, and the supply of grey water is a bit of a legal grey area, as it were, and the risk of cross-contamination, cross-connections is seemed to be too high. Next slide, please. So the London Olympic Park used a non-potable water supply produced by the old Ford Black water recycling plant, which is shown here. And one of my colleagues actually managed the system and understands how it works in great detail. All of the water discharged from our example house, except the outside use of 5 litres per person per day, could be collected and processed through a black water system. So that would use or capture 79.8 litres per person per day. Obviously greatly exceeds the non-potable demand of 28.5, but because that demand is fixed in each house, a black water recycling system wouldn't provide any further benefit or reduction in the PCC than a grey water recycling system would, unless other uses could be found for the surplus. And as the cost of a black water system would be significantly greater than a grey water system, they're unlikely to be cost effective, except in very particular circumstances. And that might include where a very large development is located in an area where both water neutrality and nutrient neutrality are required. An on-site wastewater treatment works is often part of the nutrient neutrality solution for large developments and can treat water to an exceptionally high standard. And so if water neutrality is also required, it would be possible to configure that system to generate non-potable water. In a location where surplus non-potable water is generated by a black water system, maybe it could be used in retrofits for other existing buildings or developments nearby. That's another use case. This would reduce the existing demand for potable water, and the savings could be used as an offset for the new development. And maybe there's a use case where there's a lack of capacity in the sewer or wastewater treatment works network, which means that the reinforcement costs are more costly than the use of an on-site black water recycling plant. But I think that is going to be a very small component of any projects. Next slide, please. Thank you. So moving on to alternative supplies, at its simplest, as I mentioned earlier, an alternative supply could be simply a new potable supply connection from an adjacent water resource zone that is hydrologically disconnected from the water neutrality catchment. So to benefit from that, the proposed development would need to be located close to the boundary of the WRZs, making a connection shorter and therefore cheaper. There would need to be design and construction of a transfer pipeline. And the alternative supply would, of course, need to come from a water source that has spare capacity. And as we saw earlier, water scarcity and serious water stress are widespread throughout central, southern and eastern England. And the availability of an alternative supply is likely, therefore, to be really limited, even if a development has the good fortune to be located near the water resource zone boundary. Next slide, please. If a direct connection to another supply isn't feasible, it's important to explore whether a new groundwater borehole could provide an alternative supply. The image on the lower right shows a perched aquifer. If a direct connection to another supply isn't feasible, it's important to explore whether a new groundwater borehole could provide an alternative supply. The image on the lower right shows a perched aquifer that is hydrologically disconnected from the underlying primary aquifer. That means that abstraction from the perched aquifer would not increase demand on the primary aquifer, and that offers an option to abstract water and a path to water neutrality. So if a development, is fortunately located directly over a perched aquifer, water abstracted in this way could be used for potable water on the development site, although it may require blending or treatment depending on the quality. And the yield would also need to be determined to ensure that that would be acceptable into perpetuity for the demand of the development. And that requires sinking a trial borehole for pump testing. In areas where the new development is not over a perched aquifer, water from a perched aquifer could be used by somebody else in the catchment to reduce their existing potable demand, which would then free up some headroom for the new development. For example, and this is the case of a project that we've worked on, a farmer could install a borehole into the perched aquifer to supply water for cattle drinking and irrigation that would otherwise come from the potable system. And so the reduction in demand on the potable network was then used to offset the additional demand from the new housing development. In such cases, developers and farmers may come to a direct commercial agreement, or a third party such as a drilling company may act as a broker. So the bedrock geology map shown on the left shows that Southern Water's Hardham groundwater abstraction, which is down towards the east, and which supplies the Sussex North Water Resource Zone, is located in the Folkestone Formation. The map shows that a borehole at the red dot location sunk into the upper greensand would be separated from the Folkestone Formation by a thick layer of galt clay. And so that results in those two aquifers being hydrologically disconnected. So abstracting from one reduces the demand in the other. Horsham District Council specifies that a planning application involving a borehole for the abstraction of more than 20 cubic meters of water a day must be supported by groundwater investigation consent from the Environment Agency, a hydrogeological assessment of the water yield to confirm that sufficient water is available year on year and throughout dry seasons, water quality assessment and a treatment, sampling and testing regime to ensure that the water is maintained at potable quality, an impact assessment considering receptors that might be affected by the new abstraction, and also an abstraction license from the Environment Agency. So it can take upwards of 1 year or more to obtain this information to accompany a planning application. And so early commencement is critical. And it isn't cheap. A project to sink 3 exploratory boreholes just to confirm whether water is available and in sufficient quantity and quality would cost in the region of £600,000. And we've got a project that is currently using that approach. Next slide, please. So I mentioned that if a development is located over a groundwater aquifer, it might actually be possible to artificially recharge the aquifer using rainwater or high quality treated effluent from the development. The use of harvested rainwater or stormwater would require minimal treatment, but clearly the use of treated effluent would require very careful consideration to ensure that risks to the aquifer were minimized. And I think groundwater recharge is likely to be a niche option and would require considerable hydrogeological assessment to ensure that it is feasible, successful and safe. Next slide, please. Thank you. So moving on to offsetting. So this can be achieved either directly between a developer and owners of existing buildings or mediated through a local authority or a regulator-run water credit scheme. The principle remains the same. Reductions in water demand from existing users can be used to offset the new demand from a new development. So for example, if any existing properties or businesses will be demolished as part of a new development scheme, their prior water use can be offset against the new demand from the development. And then the remaining demand must be offset against water savings from non-household properties households or through a water credit scheme. Water savings might be generated by retrofitting existing buildings with water efficient fixtures and fittings, rainwater harvesting or grey water recycling. And water audits should be undertaken to establish the baseline water usage and to inform the range of potentially available retrofit options. Given the volume of water savings required to offset new developments, it's important to focus on large water users first and retrofit efficiency measures alongside behavioural change programs and metering. Retrofitting of schools and civic buildings in Sussex North is being managed by the local authorities to generate credits for the SNOWS credit scheme. Agricultural businesses, as we've just heard, may be able to offer existing potable demand or offset existing potable demand using new boreholes or rainwater harvesting. I've seen garden centres being retrofitted with rainwater harvesting. They often have large roof areas and they have a high demand for watering the plants. And other high water users might include industry, energy generation, hotels, large hospitality businesses as well. And all of those categories, every single opportunity in Sussex North, I think they've been phoned up at least once, possibly more, by developers seeking credits. Next slide, please. So retrofitting water efficient fixtures and fittings into existing dwellings can also be used to generate water savings. However, because of the volumes required, you'll need a lot of houses. And so a partnership approach with housing associations or local authorities that control many properties is likely to offer the most effective approach. Fitting a flow control device, such as the Synergist HL2024 pressure independent flow control device, pictured here, what a title, onto the cold water feed can provide a PCC reduction of at least 27 litres per person per day from existing homes. So based on our example house, the reduced PCC of 56.3 after water efficient fixtures and fittings and rainwater harvesting, that could be offset by fitting just 2 Synergist devices or 1 Synergist device to 2 properties, assuming that occupancy rates are the same. And that would have a total mitigation cost of around about £700 per new dwelling. Alternatively, if the example house wasn't designed with grey water recycling and just had water efficient fixtures and fittings and a PCC of 85, it would require retrofitting of just over 3 houses to achieve neutrality at a cost of around about £1,000 per new dwelling. And that is cheap, believe it or not. The Synergist devices can be installed for around £350 per dwelling. The price of those has gone up rapidly in the last 2 years as demand has increased. And that's a turnkey solution. The devices have been trialled in Sussex North. They've been accepted by Natural England and they've been successfully used to offset new development by Crawley Borough Council. As the devices are plumbed in to the cold water feed, they can't be readily removed. You're not meant to tamper with the water company side of the supply pipe. And so Natural England, I think, and the Environment Agency prefer this approach to the installation of tap aerators and shower inserts, etc., because it can't be easily removed. Also, because the water neutrality issue in Sussex North relates to habitat sites, a very high level of certainty of mitigation must be demonstrated through the habitats regulations assessment. It's a very high bar to achieve. And so currently that needs to be secured through, or these devices need to be secured through a Section 106 agreement or other legal agreement. And so that's why working with housing associations and local authorities to target their stock is the most appropriate way forward. However, in Cambridge, the regulators are considering whether this approach could be rolled out to individual sort of owner-occupied properties, which would substantially increase the volume of water that could be saved. And in the Cambridge situation, focusing just on housing associations, socially tenanted properties, wouldn't be sufficient for the increased demand in the region. If individual owner properties are going to be targeted, they would require high quality and high frequency water metering to establish continued effectiveness. So the benefits of the Synergis flow control valves is that it reduces water bills by around £100 a year and water heating bills by a further £300 a year. So it offers a substantial benefit to occupants. As you can see towards the bottom of the slide, a Water UK study looked at 18 options to reduce national water consumption and found that retrofit options were the most costly, which is not surprising. And you can see here that home rainwater harvesting, grey water recycling was ranked 14th, community black water recycling 17th, and community rainwater harvesting 18th. The cheapest options were found to include media campaigns, school educational programs, water labelling, new toilet standards, metering, innovative tariffs, none of which are applicable to developer-led offsetting projects, of course, but are part and parcel of what water companies do. Next slide, please. So if retrofitting isn't appropriate, or it provides insufficient benefits, or it can't be done by an individual developer on their own, it may be possible to purchase water credits. And this is the simplest and easiest way to offset a development, assuming that credits are available, but it is also very costly. The SNOWS credit scheme in Sussex North, the Sussex North Offsetting Water Scheme, SNAPPY, is in development, and it has been in development for about 2 years now. And they are anticipating commencing credit sales in December this year. So the scheme is initially based on retrofitting existing housing properties, council properties, but will then extend to non-households as well. And the number and availability and pricing of credits still to be confirmed. So developers have been waiting a long time and still waiting. The original intention, I think, was to price credits at around £9 per litre. However, market forces have resulted in the development of private mitigation schemes in Sussex North, and they're charging upwards of £50 to £100 per litre. It's an astonishing number, and some of them are selling at that price. This is hampering the generation of credits for the SNOW scheme because developers are willing to pay housing associations large co-payments for access to their properties. And I've heard of figures of up to £2,000 per property. And obviously that's a more financially attractive proposition than SNOW's offering only a free retrofit. So as I mentioned earlier, we're working with DEFRA and other agencies to learn from the SNOW scheme and other mitigation schemes, and to develop a credit scheme for Cambridge. And the recommended approach there at the moment is to quickly unlock a water credit scheme, or quickly to develop a water credit scheme based on retrofitting existing dwellings, but doing that across the owner-occupied sector as well as social tenanted properties, and then potentially delivering or developing a proper marketplace to incentivize and unlock water savings from non-household properties. Next slide, please. So just quickly touching on commercial developments for those that contain mixed use schemes. Water efficient fixtures and fittings, again, are critical to this, and non-potable demand can be supplied through rainwater and or grey water recycling. So the situation is very similar to a house, obviously bigger scale, and potentially some more money given the value of the buildings. The BREEAM Watt 01 module categorises new commercial properties based on the water efficiency and ranging from 1 to 5 credits, 5 being the most efficient. So attaining 5 credits and an exemplary performance certificate will reduce overall water demand by 60% compared to the baseline, with all non-potable water being covered by rainwater harvesting or grey water recycling. Next slide, please. So revisiting the water neutrality hierarchy, we can see that the integrated water management approach for our example house would result in the PCC being reduced from 110 to 84.8 in step 1, and then further reduced to 56.3 in step 2 through the use of rainwater harvesting or grey water cycling. Step 3 then could achieve water neutrality through a combination of offsetting water demand from the existing properties on the site, through the yield available from one or more groundwater boreholes, stormwater recycling, retrofitting existing household and commercial properties, or the purchase of credits. And it's likely to envisage pretty much all of those, given the quantum of mitigation required. So as you can see, water neutrality strategies are not simple and straightforward. They're very involved and they are also very expensive and time consuming. While some small developments might be able to mitigate demand by retrofitting a handful of homes, the large scale schemes mean that they need comprehensive strategies, and they can be time consuming to develop, particularly if groundwater boreholes are required. Next slide, please. So while some developers are able to develop their own water neutrality strategies, wash their own faces, local authorities in Sussex North and Cambridge are developing strategic mitigation solutions to help unblock the housing plans and to help others that can't mitigate their own properties. And just going to touch on some considerations for these, because over time these may need to be introduced in larger areas of the country. Next slide, please. So the task of addressing water scarcity or water neutrality challenges can be daunting given the complexity of the situation. And there are many factors to consider. Firstly, you need a detailed understanding of the supply-demand balance, both spatially and temporally. Understanding the supply constraints, definition of future increases in water demand based on housing needs, will enable quantification of the size of the gap that has to be addressed. The image shows an example supply-demand balance from the Water Resources East Regional Water Resources Plan for Eastern England. And the blue line shows demand growing throughout the plan period, while the orange line shows the declining availability of water as abstraction license caps are introduced. And the gap between the two is the supply-demand deficit that must be plugged. Mitigation or credit scheme must be developed by those that are competent to deliver it, and the regulators will of course have a big say over whether somebody, an organisation or an individual is competent to do so. Understandably, the regulators also require that water neutrality strategies, credit schemes are robust and deliver the required outcomes. And so when developing a mitigation scheme, the approaches have to have certainty of delivery. They must be scientifically and practically deliverable. They must also be deliverable for the duration of the required mitigation. And so whether that's a bridging gap until a new reservoir comes online, as is the case in Cambridge, or for the lifetime of the housing development. And that's taken to be 80 to 125 years. The mitigation's got to be real, so can't be double counted. So liaison with the local water company would be required to ensure that you're not double counting water savings from socially tenanted properties that maybe they have got in their water resource plan as targets as well. Excellent record keeping, data management obviously is going to be essential. The mitigation strategy must also deliver benefits that meet the test of additionality. So there must be new benefits that wouldn't otherwise have occurred. So for example, if you are considering a scheme where you pay for water efficiency retrofits of business properties, it's important to establish that they wouldn't otherwise have been undertaken or wouldn't otherwise be required for compliance with regulatory requirements. As credits underpin new development, robust quantification is really essential. And so pre and post implementation water meter readings will be required to confirm the reductions in water use. And care needs to be taken to ensure that those aren't skewed by being taken on either side of a seasonal change, maybe from a dry spring to a wet summer, which could skew the data. The Environment Agency is likely to monitor the success of a scheme by assessing whether abstractions from the water resource zone have been reduced. That might introduce some complexity because the water company efforts to reduce leakage and other demand management measures may cloud that picture. And so again, robust data is required to evidence the water usage attributable to the scheme. And detailed and repeated consultation will of course be required with all stakeholders, including developers, land promoters, regulators, the water company, the community, and all relevant government departments. Next slide, please. So setting up the scheme with an appropriate level of oversight and governance is clearly important given the large sums of public money that are involved. For a local authority run scheme, the governance structure is likely to include executive and member boards and various working groups for development management, planning and implementation teams. Don't underestimate the cost and time for legal support. So this is a really significant component of the overall scheme setup costs. The development, implementation and enforcement of standards is important to ensure that houses are designed to the right standard, that water use reductions are genuine, that equipment is appropriately certified, water savings are quantified, etc., etc. And also that data is gathered, stored, managed, analysed and shared to ensure that there is scheme confidence, both amongst the regulators and the market participants. Following the polluter pays principle, those market participants who need to offset their developments should bear the cost of doing so, and full cost recovery of public monies it will require careful consideration of the cycling of money through the scheme. Clearly, administering the scheme will come with a cost as well as generating the water savings. The water saving credits might vary in price over time as the low-hanging fruit is accessed initially. And there is also an issue about how and when credits are generated and paid for. So if generated in advance and pooled, there will be a lag time from the payment for the service and the deposit paid by a developer for those credits prior to pre-planning application. And then there will be another lengthy period until the balance is paid post-planning. And of course, on multi-year phase developments, that could be several years. And so that would lock up the public money in the credit generation system without enabling the recycling through the payments. So cash flow management is a real issue, and that needs to be addressed. Section 106 agreements almost certainly going to be required at some point in the process, and Grampian conditions might be useful as well for helping with the planning stage. And in the early stages of a scheme, demand is going to almost certainly significantly outstrip supply, and so prioritization will be necessary. And that can be used by the local authority to either unlock schemes that are at reserved matter stage, those that are allocated in the local plan rather than windfall or speculative developments, or maybe to prioritize the delivery of social housing. Enforcement should be quite straightforward if there are, proper planning and Grampian conditions, Section 106 agreements that have been reasonably worded in line with condition tests. So as you can see, much to consider, and developing a water credit scheme is a serious undertaking that requires significant funding and resourcing. Next slide, please. So because they realised the complexity of it, DEFRA engaged or commissioned BSI, British Standards Institute, to develop an overarching series of principles and a framework for nature markets to ensure that the schemes are developed robustly. The standard outlines the elements we've just seen on the last two slides and more, and it's a really helpful framework to guide scheme development. Other sets of principles were developed prior to this by a consortium of UK conservation charities, Finance Earth and an ethical US investment fund, while the Environmental Markets Board has been developed by Wessex Water to oversee the delivery of nutrient markets operated by their offshoot Entrade and others. And these make interesting reading. Next slide, please. So wrapping up last two slides. So recommendations when developing a credit scheme, it's important to maximize speed to market because that facilitates continued housing supply delivery, and it prevents that ad hoc private market that risks undermining financial viability of a local authority-led scheme. And while it's important that the scheme is robust and accepted by the regulators, you shouldn't let the perfect become the enemy of the good. So instead, move quickly and adapt as you go. The regulators may want you to run a small pilot and learn the lessons from that. As one new home is likely to require the retrofitting of 2 to 4 existing homes, it's important to target the market as broadly as possible. So household and non-household, social rented plus owner occupied, where you can. Minimizing overhead costs. So I mentioned the turnkey solution provided by Synergist, and I think they are the only one in the market currently that does that. So they've got us over a bit of a barrel on price. But engaging a reputable contractor to deliver that whole service reduces scheme overheads and can be done at pace as well. Maintaining credit availability is going to be that old chestnut of supply demand and the rapid recycling of funding that I've spoken about. So, and scheme pricing is important because of the impact on the viability of a development. And as I've mentioned, that might range from around about £6 per litre for a flow control device through to £100 per litre through a private sort of purchase of credits. And clearly, the higher the credit price, the greater the impact on development viability. So having clear price stability is also important. As shown on the slide, discussions with developers in Cambridge highlighted that they place a slightly higher priority on the credit availability rather than price stability. However, there will be a threshold above which new developments become non-viable. And the word cloud shows that cost, flexibility, simplicity, certainty, reliability, and others are all key considerations from the perspective of developers. Next slide, please. And so addressing water scarcity, achieving water neutrality is a complex business. It requires multidisciplinary teams. It requires lots of consultation, lots of accurate quantification of supply and demand balance, and it needs at-pace development of mitigation and offset solutions as well. And so early professional advice is essential to avoid pitfalls and abortive work. But I would say that, wouldn't I? Because I'm a consultant. So thank you very much for joining us today. I hope the presentation has been helpful, and I'd be pleased to take some questions.
Thank you so much for that, James. That was really interesting. We've had lots of questions and comments as expected. You have probably addressed a few of them in your slides as you went, but it's probably worth revisiting some of them anyway. So there was a couple of questions about it, and you did have a slide on this, but can you give us examples of the successful implementation of black water and grey water recycling in UK housing schemes?
Yeah, so grey water recycling is being used in the King's Cross developments. So it's a big regeneration project there, lots of commercial and resi, and they're all got grey water recycling, which is great. It is used elsewhere. I think there's a scheme in Peterborough that use grey water recycling as well, but there are lots of others, and there are several suppliers that that design and supply and maintain such systems. Black water recycling, I'm not aware of at a resi scheme currently. The old Ford one I mentioned was for the Olympic Park. So I think, because it's more costly to do, you wouldn't go to a black water recycling scheme. You would go to a grey water recycling scheme because it does the same job for less money, unless there's very specific use cases.
Great, thanks. And a sort of linked question in terms of water supply and the supply companies, are there any examples of black water recycling for potable use, or is that just, are we not at that stage yet?
No, I don't think we're at that stage yet. I think there is a bit of a hoo-ha going on in the Thames about that sort of approach, but I don't think we're at that stage. And you can imagine the yuck factor, for grey water is seen as a bit of an impediment. For black water, it will be worse. I lived in Australia for 10 years, and they were quite at the forefront of this, as you would expect, and they introduced a black water recycling system, and it didn't go down well, to be honest. So.
Okay, thank you. And you did show the examples of some of the grey water systems that can be retrofitted into existing housing. So that and gave examples of those. That was one of the other questions.
I mean, the problem with retrofitting, as one of the slides showed, was that it is very expensive because you have to essentially put an entirely separate plumbing system into an existing house. So ripping out walls and all of that. So it's better to do that for new houses rather than retrofit. It's cheaper.
Yeah, so on the reducing water consumption element of that hierarchy, where water efficient appliances have been installed, what methods are there to enforce or maintain that those are retained? Because they could easily be replaced.
Yeah, and so that's one of the issues. So in Sussex North, I mentioned that because it's a habitats regulations issue, there needs to be a habitats regulations assessment done, HRA and an AA appropriate assessment. And that's a very high bar that you have to have absolute certainty that this is not going to cause a problem. So in that location, those schemes are currently restricted to large social housing providers where Section 106 can secure the retrofit in perpetuity, essentially. And where there is a professional management organisation that takes responsibility for maintaining, replacing, fixing, and also checking during void periods and annual checks that they're still in place and working. So that's the issue in Sussex North. Going to an owner-occupied situation is a bit trickier, and I think the regulators, are still going to have some thinking about that. But that would need to be backed up, probably by smart metering, so that we've got very high frequency, high quality data to establish that the consumption is still lower than it was.
Okay, great, thanks. So we've got a question about the local plan examinations, and the question is it sufficient evidence for the LP examination to say that we are in a high water stress area?
I'm not a planner, so I'm not qualified to comment on that. I don't know, Dan, if Dan is on the call.
Oh, Dan has dropped off.
Oh, has he? Right, okay. Can we note that down and we can maybe get an answer to that?
Okay, great, thanks. And the next one, what are the viability implications of going with a higher standard than 110?
Yeah, there's some work being done on it, and it's not a significant additional cost. I can't remember the numbers off the top of my head, but it's a couple of £100 possibly per new home. Maybe not even as much as that. When you really start pushing the envelope is when it gets more expensive, obviously with grey water and rainwater harvesting. But it is a very modest cost, and that would have to be taken in the round as well. If you're in a water neutrality zone, you're going to have to get to zero through a combination of those three steps.
Yeah.
And the further down that hierarchy you go, the harder and more complicated and more expensive it gets. So it's best to do as much as you can in home before looking at everything else.
The next question that I have in the list, and there've been a few comments similar. It's about why should the entire burden be on new build homes? I know you did talking about the credits and how to use retrofit as a way of offsetting the use from new build onto existing properties. But do you want to expand on that?
Yeah, I mean, there are moves obviously afoot for every water company to reduce existing demand. And there are lots of measures there. Government ambition is to get water consumption down from roughly about 145 litres per person per day average to 110 over time. I think it's a bit of a sticky problem, and the water consumption went up during COVID and hasn't come back down very much. So existing properties are obviously a large part of the problem, but water companies are trying to incentivize people to improve it. I mean, I guess, you know, it might not be seen as fair. It's like nutrient neutrality, you know, it falls on housing developers. Housing developers don't like it when a large part of the problem is agricultural pollution. I guess that's just where the policy has been set because, you know, developers, rightly or wrongly, are seen as having money and an incentive to do it because they need to get through planning. So yeah, it's an interesting proposition. But certainly, you know, paying for those retrofits is helpful across the entire catchment.
And there's also an element of to what extent can pricing be used to reduce existing consumption, or is that how does that fit in the policy area?
Yeah, again, I'm not a planner and I'm not in a water company, but you know, there are schemes looking at whether pricing signals can help to reduce consumption. Clearly, metering penetration is a big issue, and the intention behind that is to make people aware of how much they're using, and so that's quite high in some areas and less so in others. So that's incentivizing people because they see a real reduction in cost on their bill. You know, there are some ideas about increasing the price of water once you get above a certain threshold. So high water users are incentivized to reduce theirs. So I think it works. You know, and Thames Water's doing a lot on incentivizing new developments to be more water efficient, and there's incentivization processes as well.
Great, thanks. So can you maybe give your thoughts about the pros and cons of using desalination in areas of high water stress? Are there any good examples of that in the UK?
So there is a desal plant in Thames, but it's not highly effective and not used much. The longer term plan for the East of England sort of regional water resource plan is to construct, I think, up to 6 desalination plants around the East Anglian coast to supply Cambridge and other parts, which is, you know, a phenomenal undertaking. And then they've got to get that water to where it's needed and then back out again as well. So I think it's coming, unfortunately, you know, and it's crazy in my career so far. You know, it's become a pie in the sky idea to sort of reality. Yeah, it's an interesting one.
Okay, great. So I think we've got time for one more question, and so I think we're going to go with what could we do to change people's behavior overall in the sense, and to go back to your initial slide, that we live in a country where it seems to rain a lot.
Yeah, it's interesting, isn't it? Because, you know, we had all the floods last year and you know, large areas of crops were destroyed, and yet suddenly, you know, we have areas and issues of water scarcity as well. I think behaviour is a tricky one. There is an Ofwat innovation fund. I think it's £100 million for mostly for behavioural change in this sector, and so that is a really good piece of funding to drive this forward, because it is really fundamental. And I think, I was in Sydney when they had a really long drought, and water consumption was reduced dramatically because people's behavior changed. There was a very real need for them to change their behavior. And I'm still doing what I did in Sydney. Now I live in Scotland. So, that's stuck with me for 20 odd years. So once you change behavior, it can be very powerful.
I grew up in Zimbabwe during a very serious drought, and I also that stuck with me for my entire life. So
Yeah,
maybe, as you said, once people learn, then it sticks.
exactly. Yeah.
All right, so that's the end of our questions. If we could get back to the slides, please, and just start to wrap up. Thank you very much for that, James.
Thank you, everyone.
So we have this is a slide showing the sort of key takeaways from today's session. These slides, as we've mentioned, will be circulated, and you can review the links to these documents and resources. And so that's a useful resource for attendees to access. If we could have the next slide then. So the last thing to do then is to say thank you very much to James Alloway for that excellent presentation. Thank you to the team who's run the session in the background. There's a whole team of dedicated people from the LGCC beavering away to make sure that this program is successful. So thank you to all of those, and thank you everybody who's attended today's session. I hope you found it entertaining and informative, and I look forward to seeing you at future sessions. Thank you, everyone. Goodbye.
Thank you.